So in the last class, we have seen what are the different types of gradients and how to compensate a gradient if we are imposing a gradient on a horizontal curve. Okay, in the case of a railway track. So today we will see how you can define a curve. So as you all know, what is a curve? What is a curve? So any deviation from the center line or center alignment, any deviation if it happens, it is known as a curve. It is the most simplest definition anyone can give, right? But the most appropriate form to define a curve is either by its degree or by its radius. So you might have heard that people saying it is like a 100-meter radius. That curve is having 100-meter radius, or maybe some people will be saying it is a 5-degree curve. So in both ways you can define a curve. Yeah, for example, if it is in degree, you are defining maybe 4-degree curve, 2-degree curve, or 10-degree curve. Similarly, when it comes to radius, maybe 100-meter curve, 150-meter curve, or 200-meter curve, depending upon the curve that you are talking about. Okay. And again, now what I am going to talk is not new to you, because you have already gone through this session in surveying and geomatics, right? So this degree of the curve. So when we say the radius, you know what exactly is a radius. From the center, the distance to the circumference, right? Similarly, degree of a curve means the angle subtended at the center by an arc or chord of 30 meter. See, suppose you are considering an arc of 30 meter, okay? Sorry, 30 meter, and you can get the degree of the arc by the angle subtended at the center by this 30-meter arc. Similarly, if you are considering a chord of 30-meter length, the angle subtended at the center by this 30-meter length chord is also known as degree. Okay, this may be d dash. Both may not be same, because when you are using 30-meter arc, it doesn't mean that your chord is also having 30 meter. It will be pretty less than 30 meters. And when it comes to 30-meter chord, your arc will be greater than 30 meter. So this d1 and d dash and d values are entirely different. It doesn't mean that when you are using a chord, 30-meter chord and 30-meter arc, you will end up in the same degree of the curve. No, it will be different. Okay. So this is a figure in which you can see a 30-meter circular arc, and this is the angle subtended by this 30-meter arc, which is known as the degree of this curve, and this is the center point, and r is the radius. And here is the figure for this is a figure for 30-meter chord. Okay, and here also you can see the degree of the curve. Generally, the degree of the curve is denoted by capital D. Okay, and radius, just like radius capital R, the degree of the curve is denoted by capital D. That's it. Okay, and if you take the midpoint of your chord, then half that angle will be d by 2. These are all general things that you'll be able to understand easily. Now let's move to the relationship between the radius and the degree of the curve. So again, you are considering a curve, okay, whose radius is r. Then you know that the circumference of the circle will be 2 pi r. Similarly, the angle subtended at the center by this entire circle will be 360 degree. Right? Now you need to know what is the angle subtended by the arc of 30 meter. So now you are considering arc of 30 meter from this entire circle. Okay. Now you need to know how much is the angle subtended by the arc of 30 meter length, whose radius is capital R and the entire circumference is 2 pi r. So it is pretty easy. D by 30, which is 30 meter length of your curve, is equal to 360 degree by 2 pi r. So when you solve this 360 degree by 2 pi into 30, you will be getting D is equal to 1720 divided by R. Okay. So we are arriving at this conclusion. 1 degree curve, suppose if the degree of your curve is 1 degree, then it means that it has got a radius of 1720 meters, because this is a relationship. D is equal to 1720 divided by R. So if your degree of the curve is 1 degree, then R should be 1720 meters. Now we are moving to the some standard values suggested by, not suggestion exactly, I should say it's recommended by Indian Railways. So all these values we are following only in India. Okay. So here you can see the type of track. So the various types of tracks being used are, most common type of track used is broad gauge, then comes meter gauge and narrow gauge. Narrow gauge, again lighter version is there. So you can see there is a change in the gauge width for narrow gauge. Okay. So these are the gauge widths. And these gauge widths are standard, not just in India. Broad gauge means it is always 1676 mm or else 1.676 meters. Similarly, meter gauge means 1 meter, narrow gauge 0.762 meter, and lighter version of narrow gauge is 0.610 meters. These are the standard values. Okay. Now coming to the standard values recommended by Indian Railways. So whenever we are constructing or designing a curve for Indian Railways for a track section, then we need to limit the values of degree of our curve. Okay, so the maximum degree of curvature is limited to 10 degree if it is broad gauge, and 16 degree if it is meter gauge, and 40 degree if it is narrow gauge. And in this case, the radius of your curve should not be less than 175 meters in the case of broad gauge, then 109 meters in the case of meter gauge, and 44 meters in the case of narrow gauge. Okay, these are the standard values. So keep all these values in your mind. Let's move to the next section, which is super elevation on curves, or it is also known as CANT. Okay, so we have seen this super elevation in highways, and The basic concept of super elevation remains same. Okay, in this figure, it is quite easy to understand. This is the portion of bottom portion of the wheel which touches the railway track. Okay, our track or I section of the rail, and here on the outer side or the raised portion, in which you can see the outer rail which is actually raised above the inner rail. So inner rail will starts from here only. Okay, so the raising of outer edge with respect to the inner edge is known as super elevation. So here you can see our train and the wheels of the train, and it is tilted to a degree of theta. Okay, and center of gravity you can see over here, and some lateral forces are acting outwards, and the self weight is acting downwards. And because of this inclination, it has got the cos and sine components of both lateral as well as vertical forces. And apart from this, the wheel will be experiencing some friction. All those forces and frictional forces, all those loads has to be considered while doing the design. Okay, so here is a line sketch in which you can see a horizontal force which is a centrifugal force acting, and the weight which of the vehicle is directly acting downwards. Then you can see the resultant force in green rail. Again, coming to the inner rail. Okay, this is the force acting against the inside rail, and on the outside portion you can see force acting against the outside rail. And this elevation difference or this level difference is known as super elevation or simply CANT. So now move to again we are continuing with super elevation only. We will be sticking on to this super elevation, and we'll be doing some couple of problems related to this also. So superelevation on curves, as you know, it is defined as the difference in height between the inner and outer rails on the curve. And how you are providing this superelevation? When you are raising the outer rail means the inner rail will be your reference rail, or it will be in the original level as that of the uh, normal track. Okay, when the railway track is running in a straight stretch and suddenly you are encountering or you need to negotiate a horizontal curve, okay, as per your alignment you need to design your track accordingly, right? So you'll be maintaining the level of inner rail as such by keeping it as the reference rail, and slowly the outer portion of the rail or the outer rail will be raised gradually, okay, above the inner rail in such a way that at the center of your curve, horizontal curve, you will reach the exact count. So when I say you are providing a super elevation or count, or you are simply elevating your outer curve, doesn't mean that all of a sudden you are increasing the level. It is introduced gradually so that the passengers won't feel any uncomfort during the travel, or they won't feel any jerk during their travel. Okay, similar is the case with highway also. So now, what is the purpose of providing super elevation? So when you are providing a super elevation on your horizontal curve, it is actually neutralizing the effect of all lateral forces which is acting on your vehicle. Okay, and it provides better load distribution on both rails, both inner and outer rails. And it reduces wear and tear of rails as well as your rolling stock. Finally, it provides very smooth running of trains and provides comfort to the passengers. So these are the basic functions or necessity of providing super elevation. Now, let's consider a level surface. Okay, So the train was initially moving over this level surface, and suddenly you are coming across a curve, so you need to provide a super elevation. Okay, so that darker shade of line indicates that inclined line which connects the top portion of your outer rail and the top portion of your inner rail. Okay, and this is the deviation. So here comes G. This is the actual gauge of your track, and you are giving your, as you are superimposing a horizontal curve, you need to provide a super elevation over there, and finally your S will be slightly more than G. Okay, especially on the curve at the point where you have provided the exact value as that of E. And let this uh, deviation be theta. Okay, so from the figure, tan theta, you know that opposite by adjacent E by G. Okay, super elevation by your gauge. And also tan theta means centrifugal force divided by weight. Okay, this is also known to you. Now you can equate both these equations, and finally you will be getting an expression E is equal to gv square by small gr, where E is a super elevation, G is the gauge, then V is the velocity, small g acceleration due to gravity, and r is the radius. Okay, and after substituting, so moreover in India, the gauge value, okay, gauge will be broad gauge itself, so that will be a standard value. uh, and after doing all type of conversions, okay, here the G is in meter, V is in kilometer per hour, R is in meter, G is in meter per second square. So many different types of units are there. So after converting everything, this can be rewritten as E is equal to GV square by 127 capital R. Okay, provided you can give this in your gauge in meters, velocity in kilometer per hour, and R again in meters. Okay, and you will be getting the super elevation in meters. So this is a standard equation in which you, if you are substituting the gauge, velocity and radius in meter, kmph and meter respectively, you will be getting a value of E, and the unit of E will be meters. Okay, so please don't forget, you will be coming across a plenty of equations related to super elevation, and in some terminologies that we will come across. Okay, we will be using the value of E. The standard values will be represented in millimeters, and in some cases it will be represented in centimeters. So I just want to remind you that please don't get confused and mix up everything. Okay, so this is a general equation, E is equal to gv square by 127 r, in which you will be getting the value of E in meters. Now let's move to equilibrium CANT. So till now we were discussing about uh, a CANT or super elevation for your railway track, right? Now we need to know why we are providing this equilibrium CANT, or what is the need of this equilibrium CANT. So whenever in a couple of slides before, you have seen that so many lateral forces are acting on our train, right? So whenever this lateral forces balances with the V loads, okay, then at that point you can say that the CANT provided is equilibrium or equilibrium CANT. And in order to calculate the equilibrium CANT for broad gauge, meter gauge and narrow gauge, we have got these equations. And please understand that all these equations came from the general equation E is equal to GB square by 127 R. From this only all these equations came, but if you need to arrive at these standard equations, then you should know what is the gauge width for broad gauge, then what is the gauge width of meter gauge, similarly that of narrow gauge also. Okay, so if you substitute the gauge width in this equation, you will be getting all these standard equations. For broad gauge, the equilibrium CANT is 1.315 V square by R. Similarly, meter gauge, uh, super elevation is equal to 0.80 V square by R, and narrow gauge super elevation is equal to 0.60 V square by R. Okay. So these are the various equations for super elevation, equilibrium CANT. I must say this is equilibrium CANT. Okay, in which you will be substituting the average speed of the train. So equilibrium speed is always connected with the average speed of the train. Now let's see limits of super elevation. Okay, so till now we have discussed about what is E and how to calculate E based on our general equation. Our general equation. Then we have seen equilibrium CANT also. Okay, for broad gauge, meter gauge, and narrow gauge. Now, if we are calculating some value based on our speed of the vehicle, then radius and all, we will be getting some values. Okay, so without checking its safety measures, we won't be able to provide or we won't be able to design the track accordingly. Okay, and again, these limits are given by Indian Railways. Okay, so in no case the super elevation should go beyond these values. So these are the standard values. So whenever you are solving the problems, you need to cross check what you got with these standard values, whether the value you got is going beyond this super elevation, then you need to limit your super elevation values. Okay. So for broad gauge, the E maximum is 16.5 centimeters. Just listen here, everyone. Here, the limits are given in centimeters. Okay. So whenever you study, always just don't mug up the standard numericals. Along with that, you need to understand and remember the unit also. So broad gauge, it is 16.5 centimeters. Meter gauge, it is 10 centimeter, and narrow gauge, it is 7.6 centimeters. And how we have arrived in this standard values is from here. Okay, so in no case your Emax should not be less than G by 10, where G is your gauge width. Again, here gauge width is written in centimeter itself. Okay, so this is the general equation. So if you are writing it in meters, no problem, you will be getting a value corresponding to that unit only. But if you are substituting in meters and don't write it this Emax value in centimeters. Okay, here if you are substituting in meters, then you will be getting Emax value in meters. Here if you are substituting in centimeters, then correspondingly you will get value in centimeter, and here if you are substituting in millimeters, the value will be in mm. Okay, so correspondingly if you are doing sorry, in meters it will be 1.65. You can see that the value is 1.676. Okay, 1.676 meters, and if you are substituting 1.676 meters by 10, you'll be getting 0.16 meters as your Emax value. And suppose if you are writing 1676 mm, your value will be 167 mm. But when we come back, this is limited to 16.5 centimeter or 165 mm. So you have to limit it. Okay. Now let's see CANT deficiency. So just now when we discussed about equilibrium CANT, I have told you that whenever we are calculating some values and we are getting that value, we won't be able to provide it as the uh, perfect design, right? We need to think of all other things and find out whether our design is going to provide a better result. Okay? And not always we will be able to provide the equilibrium CANT practically on a horizontal curve due to several reasons. Okay, so in that case, the CANT provided, and practically what we are providing the CANT will be slightly lesser than the theoretical CANT. So always the theoretical CANT is provided based on the maximum permissible speed. And sometimes if we can't provide the theoretical CANT, we'll be giving the actual CANT, right? So what we are giving in the field or on the railway track, which is known as the actual CANT. So there will be a slight difference between this theoretical CANT and the actual CANT. So this difference is known as CANT deficiency. That much CANT value is deficient actually. Okay. So CANT deficiency is always expressed by CD. Okay, this is a notation given, and it is the difference between theoretical CANT, which is necessary for the maximum permissible speed on a curve, and the actual CANT that we have provided over there. Now again another set of standard values recommended by Indian Railways for CANT efficiency, and here you can see the CANT efficiency is given in mm. So for broad gauge, it is 75 mm, for meter gauge 50 mm, and narrow gauge 40 mm. So these are the CANT efficiency values recommended by Indian Railways. Okay. Now let's move to equilibrium speed. So we have spoke of the theoretical CANT, which is provided for the maximum permissible speed, right? But not always we are providing this theoretical CANT. Due to some constraints, we will be reducing the CANT and we will be experiencing some CANT deficiency on certain parts of the track section also. So depending, in fact, the speed of the fastest train and also the average speed of the goods train moving on each railway track has got an effect because of the amount of super elevation. You might have noticed when we are negotiating a curve on railway track, especially the speed of the trains are getting reduced. Even the fastest moving train will be reducing its speed and will be moving, right? So when we are designing a railway track, you cannot simply design the track for the fastest moving train because the same railway track will be used by uh, a passenger train whose speed will be maybe around 50 to 60 kilometer per hour, or even a goods train even which is traveling at a speed of much lesser speed, maybe 30 or 40 kmph per hour. So but you cannot again give so many different tracks for depending upon the type of the trains. Of course you can provide a entirely separate track for the fastest train, but still when you are comparing other trains you won't be able to provide tracks for each separate tracks for depending upon the speed of the train. So whenever you are designing this railway track or super elevation, you need to consider or you need to think of an equilibrium speed. Okay, so that all types of train, like even the fastest train which is running on that uh, curve with a much slower speed, the fastest train need to slow down but need not bring the speed to much lower speeds. So the fast trains can run smoothly without causing any discomfort to the passengers. Similarly, the slow running trains or the slower trains can run safely without the fear of derailment due to the excessive super elevation. So if you are providing excessive super elevation, the slower trains may get derailed from the track section. So these possibilities or these fears can be avoided if we are designing the super elevation for the equilibrium speed. Okay, or you can call it as average speed. So in Indian Railways, we are designing the super elevation for equilibrium speed or by considering the average speed. Now let's know how to calculate this equilibrium speed. And in order to calculate the equilibrium speed, we need to know like how many types of same category trains are going to utilize that track section. Okay, maybe there will be some five sorry, yeah. Maybe there are five number of trains which is moving in a speed of 100 kmph. Maybe there are three three trains which is moving three trains moving in a speed of 40 kmph. Maybe eight trains are moving in a speed of at a speed of 70 kmph, likewise. Okay, so you need to know how many trains of what all category speed category are you going to utilize that particular railway track. You need to know. Okay, then after knowing these details, you can calculate the equilibrium speed by weighted average method. And what is weighted average method? It is just multiply the number of train into its corresponding speed. Okay, then you are adding it up. Okay, so These are the number of trains, and these are the speed of your train. So Ni represents number of trains and Vi represents speed of the train. So what you can do is N1 into V1 plus N2 into V2 plus N3 into V3 plus so on, depending upon this data set, divided by, so NIVI divided by the total number of trains. Okay, for these N1, N2, N3. So here the N1 value is 5, N2 is 3, N3 is 8. Similarly, V1 will be 100, V2 40, and V3 70. So just multiply, take the sum, divided by 5 plus 3 plus 8 will give you the equilibrium speed. Okay, this is how we are going to calculate the weighted average. So all of you can take down this question. There is a sample problem. Find the speed of Find the speed for which the superelevation is to be maintained if the speeds of several trains running on a main curved track are as follows: 15 trains at a speed of 50 kmph, 10 trains at a speed of 60 kmph, 5 trains at a speed of 70 kmph, and 2 trains at a speed of 80 kmph. So these are the data that we have. So these many trains with corresponding speeds are going to utilize a particular railway track. Now you need to know the equilibrium speed, and for that you need to do the weighted average method. Take down the question. Sneha?
Ma'am,
Yeah, how to solve it?
ma'am, 1 minute.
Arundhati? Arundhati?
Yes, ma'am.
Yeah, what are the given data?
15 trains at a speed of 50 kilometer per hour and 10 trains at a speed of 16 kilometer per hour and 5 trains at a speed of 17 kilometer per hour and 2 trains at a speed of 18 kilometer per hour. And find the speed for which super elevation is to be maintained.
Okay, so what are you going to do? How to solve this? Arundhati?
This N1 V1 plus
Yeah, you need to do the weighted average method to find out the equilibrium speed or the average speed, right?
sigma NV by N N1 V1 plus N2 V2
Hmm.
അങ്ങനെ എല്ലാത്തിൻ്റെയും ചെയ്തിട്ട് ഡിവൈഡഡ് ബൈ നമ്പർ ഓഫ് ട്രെയിൻസ്.
So what is the number of trains in this case, in this sample problem?
32.
32. Okay, find out the answer.
One
Sneha,
second.
you got the answer? Sneha? Yes.
I'm doing.
Solve the answer and put the answer in the chat box, okay? Eight point 125. What is that? Am I audible?
Yes, audible.
Yeah, where is Sneha go?
Ma'am.
Silence.
Ma'am.
Ah, yeah, 58.125. What is that?
Ma'am, sigma NV by N.
sigma NV by N. And what is that? What is that? നമ്മൾ എന്താ കണ്ടുപിടിച്ചത് എന്താ?
സ്പീഡ് സ്പീഡ്
It is a weighted average speed. So remember to write the unit 58.125. Okay, and we will continue the class on Friday with another problem. Okay, thank you all.